In part 3 of lecture 7, we will discuss another example of a derived class. One advantage that we have with inherited classes is that we can write one base class, which in turn can have many derived classes. The most important thing is to make sure that it's reasonable for this class to have the same properties and methods as the base class. What this means is I can create a class for employee, and the classes for hourly employee and salaried employee will share certain properties and methods, but they will each have certain properties and methods that are all their own. We begin writing the second derived class, salaried employee, also derived from the base class employee, by writing its invariants. Every employee must have a name, a hire date, and a non-negative salary. We will use the string no-named as a filler when there is no name specified yet. Similarly, we will use the hire date of January 1st, 1000 to indicate that no real hire date has been set yet. We begin by writing public class salaried employee extends employee, and within it we define the property salary by writing private double salary. The default constructor is fairly simple. Public salaried employee. We call the base class's constructor with a call to super with no parameters because we're using the default constructor, and salary equals 0. For the conversion constructor, again we will have the precondition that the name and the date must be non-null. These are the initial values that we will be giving it. Similarly, the salary, the initial salary value, must be non-negative. The header for the conversion constructor will read public salaried employee, string the name, date the date, double the salary. After the comment telling us that we will use the base class's conversion constructor, we write super the name, the date. And after that, we write if the salary is greater than or equal to 0, salary equals the salary. We don't similarly have to test for the precondition because those other two properties are going to be tested in the superclass's constructor. Next we'll have else, system out println, fatal error, negative salary, system exit 0. This is what it will call if the salary turns out to be negative. And now the copy constructor. Public salaried employee original object. We call the base class's copy constructor with super original object. Salary equals original object dot salary. And now the accessor for salary. Public double get salary, return salary. Get pay is a different type of accessor again because pay again is not something that we actually save as a separate property. Public double get pay, return salary divided by 12. This is analogous to what we did in the other derived class, hourly employee. Now we write a mutator for salary with the precondition that new salary, the new value we're giving it, is non-negative. Public void set salary, double new salary. If new salary is greater than or equal to 0, salary equals new salary. Else, we have an invalid value, so we write system out println, fatal error, negative annual salary, system exit 0. The last two methods we write in the derived class are toString and equals, both of which will override the base class's methods by the same name. Public string toString, return get name, and then a blank, get hire date toString, and then new line, salary, and then, quote, per year, unquote. In this way, we convert the data of the object into a two-line character string. Equals we override as follows. public boolean equals salaried employee other. Return getName dot equals other dot getName and getHireDate dot equals other getHireDate and salary equals other salary. And with this, we have completed the second derived class. We're going to look at a program that is essentially a driver for our new derived class. Public class ISADemo, and within that the main method, public static void main, string args. Then we will declare the object salaried employee Joe equals new salaried employee, quote Josephine, unquote. And then new date, January 1st, 2004. And lastly, the value 100,000. We'll also have an hourly employee here, hourly employee Sam equals new hourly employee, quote Samantha, unquote. New date, February 1st, 2003, 5.50 and 40. System out println, Joe's longer name is Joe getName. System out println, show employee Joe invoked. Show employee of Joe. System out println, show employee Sam invoked. Show employee. And now we write the method show employee. Public static void show employee. Employee employee object. System out println employee object dot getName. System out println employee object dot getHire. Please notice that here we are calling as a parameter an employee object, an object of the base class, but in the main program in both cases we are passing in objects belonging to the derived classes. Here you can see the output from ISADemo. Joe's longer name is Josephine, the name we have stored. Show employee Joe invoked Josephine, January 1st, 2004. Show employee Sam invoked Samantha, February 2003. Notice that despite the fact that they are different derived classes, calling the base class, this worked exactly as we would want it to.